Okay guys, so I'm going to do an electrical load calculation, and this load calculation is going to be based on the multifamily dwelling. And the question is, using the standard method, what's the service load for a multifamily dwelling having a demand load of 137 500 VA supplied by 120 208 volts 3-phase. All right, so this question is quite common, and a lot of time we're going to encounter these questions where you have to find the load in regards the demand capacity. All right, so in this case they want us to determine the the standard service load, as it requires a demand of 137 500 VA and a 3-phase supply of 120 208 volts. So my first approach is to write out the demand load, which is 137 500 VA. All right, and we have to determine the ampacity or the load in this calculation. All right, so remember this is a 3-phase load, so we got to divide the total load by the voltage time root 3. All right, so this is how it goes. All right, so we say let I equal to 137 500 VA, and V is going to be the total voltage across the 3-phase, which is 208 volts. All right, so this 208 volts, however, is a representation of the volts between the two lines. All right, and that is, all right, so the 28 represent VL. All right, and that is a line voltage. Okay, so you're going to determine the load for this question. All right, which is really our ampacity. Okay, so we're saying that this is IL. I'm not going to say IL, but this is V times I really. Okay, so remember V times I will give us the VA load. All right, so we want to find the load for the service. All right, so the service load is equal to 137 500 VA divided by, remember this is a 3-phase. Okay, so we have to divide it by root 3. Okay, times 208 volts. Okay, so always remember where we have phase, or we call it 3-phase, load, that we should determine using the root 3. Okay, and how that comes about now to find our surface demand is that we got to divide the total load by the 3-phase times 208 volts, which are VL. All right, so I'm going to determine that solution. All right, so 137 500 divided by, say, root 3 times 208 volts. Alright, and so the final result is 380, 81, 66. Alright, so that's 38166. That's ampere. Alright, so final answer would have been 381.7 amps. Okay, so I'm going to use this number here and determine what the size service that is required. Alright, say we want to determine the conductor size. Alright, we already have completed the question because the question just asks us to find the load. So the load would have been 381.17 amps. Just a pointer here because I want to help in determine how to calculate a service conductor. So this is a representation of the ampacity that will flow in the conductor of the service. Alright, so if we to determine conductor, alright, our conductor size, we're going to use, alright, so we must use article 310, right, of table 310 15 B16, right? So we're going to use table 310 15 B16 to determine our ampacity requirement for this conductor. Alright, so looking at this table here, alright, I'm just going to zoom up a little bit so we can see what the number will be. So my ampacity here would have to be determined by of this that the conductor would exceeds. I would have to determine that using the 75 Celsius column rather. Alright, so anything greater than 100 ampere, we would use our 75 Celsius to determine the ampacity size. Right, so the value that we had determined was 381 from our calculation. So we're gonna go down the column here under the 75 Celsius. Alright, for any value greater than 100 ampere. Alright, so that can also determine within the article of conductor size requirement. So we had 381, alright, and that is roughly 500 AW3 or kcm. Alright, so we had 800 amps, 381 rather. So our final size would have been 500 AW3. Alright, so our size conductor would be 500 kcmil. All right, so that is the final determined ampacity of the load for this calculation.